Hello and welcome to another session and episode of JaRu, a series where I just read effective Java and try to apply what I've read to idiomatic Rust. And then we can just compare because with the book there comes the example code, so it's easy for me to basically just use this to create something that could be considered idiomatic Rust, right? Also with a different structure as we see fit. And it's quite interesting sometimes to see how you would do it. And that sometimes is actually much nicer if you are able to use closures, right? Which is right now not really possible. In Java, everything must be a class, basically. All right, so what's up next? Item 2 basically is, where is it? So that's the factory stuff. So there are disadvantages here. Yeah. It's kind of, if you think about it, it's nothing special, the disadvantages, it's really just like logic applied. The next thing is the builder pattern. I think that's item 2. And we are still in the realm of object construction. Let's see. So here we have item 2. I might just close these guys for now and see how that looks like. Oh, wow. So that's individual packages now. So we have a telescoping constructor. And that's quite interesting. So basically one constructor calls the other one with null values respectively in order to get everything set. At the minimum, you have to set the non-optional things. And here we get into something very interesting, because whether or not something is optional and how you would handle this. That's a very simple struct-like class, right? And stuff like this, I think you wouldn't necessarily think about. What happens if in Rust, what happens if you run this? What do we see? Okay, we see nothing because this does nothing except for creating an object accordingly. So the bad thing, I think, about this is that a plain old data type is used to indicate that it's unset or not. So you just set these values 0. So that's probably working, but you totally remove the information of whether or not this value was actually provided or not. The good thing is that the default values are totally working or totally under your control here because you are setting them. But, and you basically just call yourself, and this kind of recursive call or downward call makes it all happen, which is interesting for an interface, I must say. Something I find also interesting is the choice of type here, just because it's integers all the time. Is there no uint in Java, by the way? Uint? Because we lose precision here. Java has no unsigned integers. Whoa! You can define a long instead of an int if you need to store large values. So int is 32-bit, long is 64. Whoa! Oh my. Okay, so in Java's E8 and later, you can use the int data type to represent an unsigned 32-bit integer, which has a minimum value of 0 and a maximum of 32-bit. Use the integer class to use int data type as an unsigned integer. Okay, so integer class would then mean that, oh my. No, that int variables are still signed when declared, but using, so this basically means okay, that's very interesting. I didn't know that at all. I wonder what we get if we get the length of an array or something. Let's have a look real quick, because it should return a long, right? I mean, this is basically, it should return a size, and size is still platform specific. So how is that solved in Java? In Rust, you have usize for exactly that purpose. And you have I32, U32, U16, and so on, which is very explicit in what value domains each of these primitives have. Here, it kind of repeats the same mistake that C++ does. Int and long. Oh, did you know that long is 64-bit? No, not obvious to you. Oh, did you know it's signed 64-bit? Oh my. I am surprised. I'm really surprised now. Shit. So what do we do with arrays here? Is it even called an array in Java? Java array? Length. Show me the docs. Where's the array's length property defined? Okay, so he just drops it into an integer. Public final length, which contains the number of components of the array. Length may be positive or 0. Arrays are special objects in Java. They have a simple attribute named length. Okay, that is that. Is it an integer? They're part of the language itself. Okay, so an array might be more like a slice then, huh? That's probably... That's a vector in a way. But can it... Is it true that this is 32-bit only then? Resource, JLS arrays. It's an int then, huh? That's weird. So they basically drop 1 bit there just for the reason that they have an assigned value for the length, which is definitely never 0 and never less than 0. All right, good. But that's not what we wanted to look at, right? We want to look at these kind of constructors. So let's have some playground here. Chapter 2, cargo new item 2. Here we go. Let's get the lib right away. We can close that one and that one. And I think I will start off as I started before. I'll just go in here and, let's have a nutrition facts type. So here, let's pretend we will offload. Let's do this right away, should we? So let's have a unit rs. Make dir tests, and then I kind of like integration tests, or I like to move the unit tests into their own module that has to import the crate, because that way, let's be lazy for now and just get everything, because that way we are basically forced to get the public API right. So nutrition facts. And we have, so public final, that's static stuff, right? So interestingly, so that's like constants. Interestingly, in Rust, you can't do this. You can't just say, well, it's const uint serving size. Doesn't work, right? So you can, oh, damn it. You would have to specify it like this, kind of. And then you have a uint here, right? But that just doesn't cut it. So no, you can't do this. And you don't have uints, you have U32, obviously. So it's yeah. So I have to get from C++/Java-ish mode and switch to Rust, just as I happen to switch my paints here. But yeah, kind of works. So that's the U32 for me, because the serving size is in milliliters. And what's always bad is, I think, if you don't have a way to specify what kind of unit you want here, right? So I really would like to make it super obvious to the programmer and say, well, if we have units, then we specify it here. It would even be better if you would use Rust units here. Rust unit. I mean, not that unit type, but there must be a crate. Because I've seen it, which allows you to specify units and then do unit conversions and have it baked into the type. Units of measure for Rust, easy to use, type safe and customizable. quant, not ready to use it. It makes you to work with dimension, unit, physical qualities. So these two, I don't know which one is better now. Crate has been yanked. Units. Let's see. That might even be the one that I have seen. See, that's exactly what I mean. So that gives you a macro to easily define your units in a particular way. So that's cool. And then you have unit conversions. My units F64 and also the dimensionless unit 1. Okay. Yeah, but we might try to use that just for the fun of it. I wonder. Does this then generate units for all the different types? So we have F32 as well. Looks a bit like it. It's currencies. So I don't know why he imports euro then if it's not even used. Basics. I think that's what we have seen in the README file. Yeah, so that's what I would prefer to use, but probably there's something similar in Java as well, and we shouldn't use external crates to simulate that. But I would at least say in Rust you would at least not only document this, but you would actually place it. I would do that at least. Let's do that, because that makes it clear what you're working with when you're doing some math. So servings is a U32. You know, they go for ints all the time, or the left side goes for ints all the time. So I go for U32 all the time. And then we have the optionals, right? So it's only these two that are required. So we have calories. That's an optional U32. Then we have fat, which is an optional U32. Sodium, an optional U32. And last but not least, carbohydrate, which is an optional U32. You guessed it. Cool. So that's a type definition. Short and concise. And the good thing is that the default is easily implementable. So let's have the default constructor, or the standard constructor here. So in the Rust world, you would do nutrition facts new, fn new, which shall return nutrition facts, and we will take serving size in milliliters in U32 and servings, which is just an amount in U32, and then it's really as easy as it's the question. You know, now I would have to list everything here, even the optionals, and I'm kind of the lazy guy, and I would prefer to have a default constructor that just goes 0 on these. So the obvious way to, by the way, calories, that's clear, fat, actually calories, so that's not kilocalories, it's calories, fat in gram, sodium in milligram, and carbohydrate in gram. Yeah, I was saying that I want the units in there, and while you're doing this, you see the kind of inconsistency. So here, calories is the unit already. Here it's something else. Maybe it's just an accident. Maybe there's something that one could figure out to do better. I don't know. I'm just saying. So service size, serving size, milliliter. Like this. Okay, then servings, which shall be serving, and the rest is all none. I'd love to set it default to set the rest to default, but I can't. I don't know, at least. Sodium none, and carbohydrate in grams none. Okay, so that's the default constructor. Obviously, the user could now set these fields. Actually, you can't because they are private. So yeah, you can't set these fields. The user can't. You can create one of these, provided obviously that we pop them. So let's have a test here. I don't know why my item 2 cargo isn't showing up here, but it probably will. Instantiation again. So nutrition facts new. I should be able to do this. 248. Let nutrition facts be this, and that is that. I can't do anything with that one. And obviously, we could now implement different static methods for this. We don't have a constructor in Rust, so in order to really do this, we would now have to provide individual constructors or individual static creators that take all of these variables and put them where they belong. Yeah, which is totally repetitive and very annoying, and I probably wouldn't want to do this. The good thing is that in the variables we already have all the information we need to say yes, these are optional, and yes, these are non-negative, and we could even allow direct access to them, And this is, I probably, it shows that it doesn't scale well, and that's cool, but I probably wouldn't do it that way. I would try to get, or to put the constraints into the fields themselves. And if I can represent this using the fields themselves, I would make them public, of course. And if I can't represent it, I would have some sort of access constraints on them and probably just provide an interface for this. Yeah, so that is that. Let's test it. Cargo test lib. Oh, actually we don't have lib test. Cargo test unit. And there we go. Yeah. Can I just call this without doing anything with it? I can. Good. So that is that. That's the kind of telescoping thing. Even though the whole idea here is to show this type and show how it's how it handles itself in the different various styles. So here we have the setter stuff without a builder, Java Beans style, which is a problem because of consistency. You're not forced to make any of these calls, and the type itself must always consider that it's in an invalid state. So the good thing is, again, that with this kind of style, you have to deal with variables that are not set anyway, right? So we are kind of avoiding this from the very beginning. The best thing for Java here seems to be the builder, and it's quite cool if you look at it that you can have nested types, right? So nested structs. This is something you can't do in Rust, admittedly. So you can have nested modules, but you cannot nest struct definitions. So then, like nutrition facts builder, you can't have. But what you could have is a static method here that gives you a builder. So let's just put this in, right? So that's always our base here. And to make it more comfortable, I don't know, you could have a builder. So in a way, you could implement, oh, we have that already. We could implement nutrition facts and have a builder function that returns a nutrition facts builder. But again, this type would have to be implemented somewhere here, right? Yeah, and if that is the case, then there is no real point to this. We could do that, but yeah, I don't like that anyway. I think the builder in this particular example, in my example, is really just a tagged on thing, and I'm not sure how many types I have in this crate, so I would probably go with this name, nutrition facts builder. If I had a module name that would say, okay, it's nutrition facts, then we could obviously simplify the names, but for now I think going with this would be good. So interestingly, what I would probably do is have an inner type here and make this a nutrition facts, because this has no constraints on it right now, and I would say we can use this to our advantage, even if this was not public anymore, right? We could access these fields, because whatever is in the same package in Rust or in the same module in Rust can access each other's fields, even though they're not public. So in a way, this would be very close to the Java implementation. And we have a constructor that does the right thing. And if we really wanted to have a builder, then we would probably do it. I would probably do it like this. So we have a builder that keeps its interior all right. Then how is it set up? Nutrition facts. Okay, so it has the default constructor already. So that's basically something we have to just copy here, even though we will return a builder. Provide a nutrition facts builder where the inner is nutrition facts new, and then we have serving size milliliters and servings just here. So that's our inner where we start with, we return that, and we are done. Then obviously we need all these setters, and yeah, well, I am wondering, it's all optionals for us, and I would probably, instead of copying this, have a little macro here that does it for me, because it's very similar, same type even. So yeah, let's have it. Brain, we've done that last time, so it's, I think that is, what do I want to have? I want the variable name. Yeah, I just take the variable name here. Name. So that's the variable name. It's an identifier, like so, huh? And then we should be able to just provide the implementations here. And the cool thing is that we can, yeah, I'm not sure if you can just stop this here. Let's try. So you would need a pub of n name, and then we have a name which is always a U32. That's something we could parameterize here, but right now we don't. And we return a nutrition facts builder. And oh yeah, we have a self as well. We consume ourselves because we have to return ourselves in the process, and then we should be able to say self.name is self inner name is some name, because these are all optional. We really just know a lot of stuff here about our types, and this must match now. So yeah, well, let's see if that compiles. It does, and let's see if we can actually use it. Oh, do I call it name? Setter. Let's call it setter. Setter for calories. Yeah, I need to do this, I guess. Oh. Do I have to call myself Matt here? I think I have to, right? Because I am actually changing myself. See, and there it goes. Cool. And this is how I can just easily reproduce all these fields now. I could even rewrite this to loop over that, actually. Totally so. Let's rewrite it to loop over that. And I think we have had this here. So there we go. We just put this around. Let's see. Okay. Let's try that. So let's try to do 2 here. Like this, huh? Calories and then fat in grams. I don't know why it hates it. Maybe it hates it because we don't support that right now. Okay. That was kind of expected. So now we say this and that-ish. So the spaces I think you need. Yeah, so that seems to be all right, huh? Seems to be what it needs to be. So what does it mean? I think this means we can repeat this as long as it ends with a comma. The question is, and here it probably doesn't work anymore because we have to unfold it here, right? So we do this and that. And now this probably is unfolding the name and drops all these in there. It is. Wow. Amazing. So now we can basically implement all of that. Sodium milligrams, carbohydrate in grams, and we are done. So the cool thing is it tells you that these fields are now used because we have code that does indeed use it. So that's a cool way to make a setter, right? Without, honestly, macros have a very interesting, say, way of being specified, but in a way, it's super cool to have them already, and I wouldn't want to miss them at all. And we have to be careful about the hygiene, right? I think this one is fine for us. We also don't export it, so yeah, we are good here. So let's have a new test that says instantiation with builder. So nutrition facts builder, new, then we have 240 and 8, and then we can go ahead with sodium in milligrams, 100 or something. And let's see what he does. We probably just take the same thing because we can. Even though our types are better. Like this, and at the end, we're saying, I'd say, I know it like new. Well, let's have a look. There is a builder pattern, a very prominent one in I/O. It's open options. That's a standard builder, and it creates stuff with open, right? So at the end, you have, okay, do it, and it can fail, obviously, which is, once again, error handling, failure handling in Rust, which is, I think, much better than the one that you usually see here. Because this stuff can still fail. And here, if it fails, it's supposed to throw an exception. And again, it's not checked unless you throw a checked exception. So I would go with new and unwrap, because I assume that this will actually have the option of failure if there is something. And this failure, how do we do it? I mean, the builder shouldn't check anything. Right now, the builder can set all of that stuff, and he will. So I guess... Oh, we have new already. So, haha. So that's the new builder, and then we say build. Okay. Okay, let's do build then. Yeah. We consume self in the process. And that's interesting. You actually want to be able to create multiple objects with the same thing. That's a benefit that's described in the book. But with that builder pattern here that I have right now, this is not possible. Because we are consuming ourselves here. This builder, though, it will not consume itself. It will actually not change itself at all. So in the moment to make this work, I think we wanna make this clonable, which can be auto-implemented nicely. And then there is not much more to it. Then we don't have to consume ourselves and we are good. We shall return a result, which has a nutrition facts in the OK side, and in the side, we would have some kind of, error enumeration usually that says that something was failing or something. Pub struct consistency error. Let's call it error. Yeah, it's an enum. And I think we just go with what can be fat. Fat cannot be 0 fat something. So if something didn't pan out is obviously a ridiculous name for an enum variant. But I say, well, I provide a string with all the information that you would possibly want. So that's basically our enum type. The cool thing is that we can extend on it as we see fit. We can improve this. And then I guess we would have a check consistency method here that would return a result. If it's okay, nothing happens. Otherwise, it provides a consistency error. And we can just provide this here like that. So we make a check on our internal one. And if there is an error, we will return it. Yeah, I think I would just match on this self inner check consistency. If we have an error, then return it. Otherwise, we don't care about this result, or we say, well, it should be unit. And I prefer this because that alerts you if there's anything else than unit at some point being returned here, and you can easily see where you have to adjust your code or deal with it, possibly in some way. And if that's the case, we say self inner clone and produce a nice copy of this. So that would be the pattern applied here, I think, in a rusty way. That's how I would prefer it, because that provides most flexibility. And the builder basically assures that whatever you build is consistent. Otherwise, you don't get one of these objects back. And that is that. So check consistency here. We could always return one of these here. Consistency error, something didn't pan out. This is not really implemented. We need a string. So to own should be what we do here. And that is that. We could also use a string slice here, obviously, but that would basically prevent us from using dynamically located strings, which could contain the values themselves that didn't work, which probably is what most people will want, especially in the error case. It doesn't really matter if we locate a string there. I mean, let's keep it flexible. Decision is something I can live with here. Yeah, that is that. Check consistency. Awesome. And did we call it here? Yes, we did. So that should work for us. Let's build it and let's make an assertion here. Yeah, I mean, this should just work, right? And here we could actually check that, what should we check? That this is an error. So we could do this, provided this is, yeah. Let's do a simple assertion and say, well, this is an error, and that is that. Why? Because we say so. Like that. That looks pretty good. Build is error, and here we go. Cool, so that is expected to build and work. However, I forgot to wrap this into an variant. No, not but just That looks good. And now no method named sodium. Is it sodium gram or something? Sodium milligram, see? Yeah, I just copied this. Carbohydrate in gram. Calories should work for us. Okay. So that is that, right? Why does it not understand that extern crate is totally fine here? Yeah, that would be the implementation. Kind of a mix of a builder supported one and a non-builder supported one. If consistency is an issue, I think I would either indeed make these private as they are, or use the builder. Or check consistency is probably always good to have, because that makes it explicit what's going on, puts a little bit of power into the programmer's hands. Question is if you want that or not. But that's kind of the Rust version I see fit for this pattern here. The builder pattern. Again, it's quite interesting. It's quite interesting how this works. So you have these constants here that can never be changed. There's no real... Is there a notion of constantness here? No, right? So that's kind of implicitly... No. Unless you make them final, maybe. Maybe there are final methods as well that are not allowed to change. Yeah, I think that's how you do it, huh? But something you have to do explicitly. Yeah, well, interesting. But I think that's it for that item. Thanks for watching and have a great day.